Looking at section 8.2 problems. So if we look at number 6, okay, on number 6 they talk about the claim when parents use XSort method of gender selection, the proportion of baby girls is greater than 5. So we have a claim that's stating the proportion is greater than 0.5. So basically we're talking a percentage is greater than 50%. The latest actual results show that among 945 babies born, we have a method of gender selection where 879 girls. So we have a number of 945 total, with stating that 879 were girls. Okay, so this was births, and then we have our girls. On here it tells us to state a conclusion about claims in exercises 4.5. So part A says express the original claim in symbolic form and then identify the null and alternative hypothesis. So basically this is part A. Part A, we talk about the claim as being greater than 0.5. Now in part B talks about the null and alternative hypothesis. So our null hypothesis, P equals 0.5. Once again, the null is always equal to the value that we're representing towards a claim. The alternative hypothesis now, so A sub 1, or you might see me write A sub A, or H sub A, sorry, H sub 1 or H sub A as the alternative hypothesis, or the alternative hypothesis, basically here would be our null or our original, and then the second version, or the one right there used. Once again, because the claim is talking to being greater than 0.5, that needs to be represented somewhere. So the claim would have been equals, I would use not equal to take out everything in there. But in this case, because it's a one-tail, we have to use that P is greater than 0.5. If we look at number 8, on number 8 here now, they tell us that the claim, the standard deviation of pulse rates of women is greater than at least 50. Okay, so once again, at least 50. So if we look at our claim, our standard deviation, so once again the standard deviation is at least 50. So at least 50 would be greater than or equal to 50. Then it says for the random value of adult females in data set 1 of Appendix B, the pulse rate have a standard deviation of, so they talk about we have a sample standard deviation of 11.6. So this would be our sampling method that we'd be using for our testing. Once again, this is our claim. We want to then in part B set up our null and alternative hypothesis. So our null hypothesis, standard deviation equals 50. Now on this alternative hypothesis, what we're going to look at on here is we're going to look at, well, if our claim is greater than or equal to 50, I can't have the alternative and the null. So I can't have both of these representing the same thing. So in this case, our alternative hypothesis, we're going to state is less than 50. That way, we can either fail to reject this, in which it could equal or be greater than, but the alternative then is testing the not of what this is. Okay, so in 6 here, our alternative is our claim, and the null would not be it. In this case, the null would be referencing towards the claim, and the alternative would be not what this is. So we have to remember that one of these, either the null or the alternative, cannot be the claim, and then one is referencing towards the claim. We can't have both being part of that. So then on number 10, number 10 says, okay, go back to exercise 6. And it says, that if we look at this, it says use only the rare event rule, make subjective estimates to determine whether the results are likely, then state a conclusion on this. So if we look at number 10 here, it says that we're to reference back to this problem. So if we look back here, we look at the simple fact that our p hat, okay, would equal 879 divided by 945. So if we consider what this is right here, we bring in our calculator. Once again, 879 divided by 945. We would be at 0.930. So as we look at what our claim is, we're looking at, hey, we got 0.930. Once again, we were testing towards that 0.5, and that we're greater than 0.5. So 0.930 definitely is greater than 0.95. So what we would state here is we would state there is sufficient evidence to support the claim that when parents use the X sort method of gender selection, the proportion of baby girls is greater than 0.5. Okay, so once again, if we think about this, our conclusion is a complete statement towards what's going on. As we're considering this, we got to remember that our alternative hypothesis really was relating to the claim. So we can support the alternative, but we cannot support any null ones. So basically what we state here is we reject the null. Okay, so there's a reject the null on this. Reject the null hypothesis. This would be kind of issued in here. Once again, we're using a generalization and not formal testing procedures, so that's why I didn't state that before. But we just kind of clearly looked at generalizing what's going on here. On number 8, once again relating to number 12, so I'm just going to write number 12 right here. So if we look at what's going on here with number 12 tells us to reference back to this, and it says, well, standard deviation is 11.6. So if we see our standard deviation, once again, it is relating to, whoa, we're definitely below 50. So this is definitely going to be below 50. So in that case, we're falling into this category. But remember, the claim was saying we're going to be equal to or greater than that. So now there is sufficient evidence. I better come to the clean page right here. Let me go like this. Grab a clean sheet of paper here. So let's bring number 12 down here. So we see that this is definitely below, so it's in this, so that means that we're rejecting this, but remember this would fall into our claim. So there is sufficient evidence to reject the claim And then we would state what the claim was. So the claim would then follow. There is sufficient evidence to reject the claim that the standard deviation of pulse rates of adult women is at least 50. Okay, because once again we're testing in this area. Let's go to number 14. Okay, on number 14 here, we're talking about a claim that among those who file tax returns, less than 1/2 of them through an accountant and other tax professional. The Fellows survey of 1,002 people who file tax returns shows 48% of them file through an accountant or other tax professional. So it's asking us to find the value of the test statistic in reference in here. So when we're relating to this, first thing we got to realize is, what are we relating to? Okay, so as we're considering this, we're relating to a proportion because they state a percentage. And our percentage is relating to that less than 1/2 of them. So our claim is less than 1/2 of people use an accountant. Okay, so that's our claim, that less than 1/2 of people use an accountant. So now our null hypothesis is going to be, because it's 1/2, it's a proportion, 0.5, so we're going to equal 0.5. Our alternative now is going to side with what our claim is, because once again, if we equal here, equal is not in less than 0.5. So that means our alternative would have to be our claim in this part. Now what we want to do is we want to make sure to check requirements for proportional. Okay, so we're going to go through our check. We're going to look, does NP greater than 5? Okay, so if we consider this, there was 1,002 people in this, and 48% use it. So that's 480.9. So yeah, that's definitely greater than this. So we're seeing that we do meet our requirements here. So because we meet this, we will come to our z-score. So our z is going to equal, once again, our percentage we're looking at, minus 0.5 divided by the square root of 0.48 times 0.52 all over 1,002. So this tells us a negative 1.27. Okay, so once again, our critical value here is z equals negative 1.27. And so then we would go to our z table and be looking for that value of what's happening. So it's kind of relating to what are we stating, what are we relating to, and then once we make sure this is our critical value that we work with now, because we're less than, makes sense if we got a negative in here, because that would be to the left of our mean in the middle there of our graph. Let's go to number 18. Okay, on number 18 it says our test statistic of z equals negative 2.0 is obtained when testing a claim of p is less than 0.5. Okay, so very similar to what's going on up here, but they're saying, let's say our test statistic now is a negative 2.00. On this part, it's asking us, assume the significance of alpha. So they tell us alpha equals 0.05. We're going to use the given statement and find the p-value and critical values. So as we look at this, what we look at is we look at, first off, this is a left tail, because once again we're less than this. So we're looking at our normal curve, and we're stating that, hey, we're going to be less than what this is. Once again, they talk about that our alpha equals 0.05. Okay. So if our alpha is 0.05, so alpha is 0.05, and this is a one tail. Okay, so because we have this, I want to refer you back to page 399. Okay, on the bottom of that page 399, it says for a one-tail test, an alpha of 0.05, we're at a 90%. Okay, so we're going to be referencing back to a 90%. So if we consider a 90 percentile on our table, our critical value then for a 90 percentile would be a negative negative 1.645. Okay, once again, if you go back to our big old tables that we have in there, let me see if I can grab mine out. On the very bottom right here, let me just bring it up a little here. The very bottom right here, we see that a 90 percentile or 0.90 is 1.645. Once again, because we're on the left side being less than, it would be a negative 1.645. So what this means is this critical value is going to be right here, negative 1.645. And now our z value that we came up with would be a negative 2.00. Okay, so we're seeing that our test value is within our critical area. Okay, and once again, this is just kind of showing you how we're using this test statistic to figure out what's happening with it. In order to find our p-value, for that p-value, what we would do here is we would go to our table, and on that table we would look at negative 2.00, which would be 0.228. So what that's telling us is, another color in here, that the area in here is 0.0228. So another way to think about this is that if we're talking about that 0.05, this is less than that. So once again, it's falling that this area in here is less than the area of this critical value, once again, which is what's relating to this significance down here for that critical value. What we start using here is we start using the fact that as we look at everything, we have to decide whether, hey, is this acceptable, is it not acceptable? If we're in a critical area, that means we have to reject, and then we got to start testing towards our claims. So let's look at number 28. So on number 28 here, they talk about that we have a significance level. So our significance level, alpha equals 0.05. And then we're going to use this given information. So they talk about our claim. Okay. So our claim is women have heights with a standard deviation equal to 0.5 centimeters. Okay, so once again, standard deviation is going to equal 5.00 centimeters. Sorry about that. They tell us we use this test, we did our hypothesis testing, and what we do is we found a p-value that equals 0.0055. Okay, so what we see here is that our p-value is less than our significance level. Okay, so we're showing the area is actually smaller than what our significance is. So what we would state on here is that, well, because we're in the critical area with our test, we are, for part A, we will reject the null hypothesis. Okay? So remember, the null hypothesis would have been this right up here. So if we come back, we state our null hypothesis, standard deviation equals 0.500. Our alternative hypothesis would be the standard deviation does not equal 0.500. Once again, we can't say greater than or less than, so we say greater than. What about the less than part? Because here the claim's equal. So what's the other version of equal or not equal, you know, is what the alternative would be. If we're saying is greater than 5, well, then what would be less than or equal to, in which then the equal is there. So this would be a two-tail that we'd be looking at on here. Because we're given a significance level and a p-value on here, we see that this is smaller than our significance. So that means we will reject our null hypothesis. Because we reject our null hypothesis, now we want to test the claim, or state the claim. The claim was the null hypothesis. So remember, we can't say, oh, we support this null hypothesis. No. We actually rejected this null hypothesis, and that's what our claim, so we're actually rejecting our claim also. So basically, there is sufficient evidence to warrant rejection of the claim once again, that women would have a standard deviation equal to 5.00 centimeters. So we would always continue to state this claim, but I'm trying to save some time in this video for you, so as we go through. So there's a lot of things that go into these problems, a lot of issues that could come about. Once again, one tail, two tail, what are our critical values, z-scores. Let's look at number 30. Number 30, once again, says, okay, so we're going to have a 0.05 significance level. We're going for the X sort gender selection, proportion of baby girls is different from 0.5. We sample data consisting of 55 girls born in 100 births. So the sample statistic is 0.55. Results in a z-score of 1.0, standard deviation above 0. So in part A, it says, what is the null and alternative hypotheses? So our null hypothesis talks about an equality. Once again, we're talking about a proportion equal to, and we are breaking the fact that is different than 0.5. So once again, that 50 percentile. So our alternative would be does not equal 0.5. Okay, now this is our claim. So our claim is saying that it is different from 0.5. So it could be below, it could be above. It doesn't really matter. That's what we're testing towards. Part B asks for the significance level. Our significance level, they told us alpha is 0.05. Part C, so in part C here it says, what is the sampling distribution of the sample statistic? Okay, so we have a normal distribution. Part D asks us, is it two-tailed, left-tailed, right-tailed? Once again, does not equal, so we have a two-tail. Okay. Part E asks us for the test statistic. Okay, so the test statistic here, they told us was a result in a z-score that is 1.00. So z equals 1.00. If we consider what's going on here for part F now asks us what is the p-value. Okay, so the p-value now is what we have to start considering. So what we're going to do is we're going to go find our 1.00. Okay, so let me get this right here. So as we see kind of in our table, we have 1.0, and then the top part would be that 0, 0. So right where my thumb is there, we see that we have 0.8413. Okay, so we're seeing that 0.8413. Now do remember, with that 0.8413, okay, that's where our 1.00 is. That's talking about all of this. Okay, do realize we are referencing the other side and then what would be referenced and doubling it here because of that two-tail experiment. So we got to take 1 minus 0.8413. This gives us 0.1587, and then because we're a two-tail in here, we're going to take 2 times 0.1587 to give us 0.3174. Okay, and so this is what our p-value is. Okay, so this is what our p-value would be then. Part G now. G says that, well, if we were given a thickness level of 0.05 and a two-tail experiment, it asks us, once again, what would the critical value be here? So bring you back to that page 399, where I said you're going to want this page bookmarked for easy referencing, or at least have it written down. So if we talk about two-tail 0.05, so two-tail 0.05 gives us a 95%. Okay, so we're talking a 95%. The 95%, once again, coming back to the bottom here, 95%, that 0.95 confidence level is 1.96. So we're looking at a z equals 1.96. This would be our critical value. And then it asks us on here, or a negative 1.96, once again, because it's a two-tail, we could be here or here. That's going to be our cutoff points. And then part H then asks us what is the area of the critical region. Once again, that is our alpha. So whatever we're doing on here as we start looking at this, we'll get more in depth into all these testing in here. But this is kind of the entire problem, and we'll start going through. Now, once again, we won't be doing the critical value and the p-value for everything. We'll be going one way or another. But as you're considering this, you really have to realize that 1.96 would be here, so our test statistic is not in that critical region. So that means that we would fail to reject. Okay, so just kind of extending this, this would be a fail to reject the null hypothesis. Once again, because over here is at 1.96, and we're testing in here within that main brunt of that population. We're not on the outside where that two-tail would be over here and here. So because of all of this, we do have to consider the fact that we can't reject that it's right here. Doesn't necessarily mean that we're here. Does not mean it, but it's just something we have to be considering with everything. The last thing this section had was our testing errors. Okay, so this is something that we don't focus heavily on, but is an excellent thing to know because things can happen within problems that, oh wait, this just isn't making sense. So if we look at number 32, number 32 talks about type 1 and type 2 errors. It talks about the proportion of gamblers who consistently win in casinos is equal to 0.001. Okay? So we're talking P equals 0.001. Okay? If we were to, it tells us that if this were a type 1 error, okay, so if we had a type 1 error, okay, what this would mean is that in reality, our percentage equals 0.001, but we reject this claim. Okay, so if we had a type 1 error here, that in reality that only 0.001 percentage of people win in a casino, this is what it is, but we for some reason rejected that fact, okay, and said no, it's not that. That would be a type 1 error. An example of type 2 error would be that in reality P does not equal 0.001, but we fail to reject P equals 0.001. Okay, so once again here we're showing signs that, hey, this necessarily is true. We're not rejecting this. But in reality, we should be rejecting it because it's been proven one way. That's what type 1 and type 2 errors start relating to. It's basically one way or another, that it is this and we reject it, or it's not this and we fail to reject it, versus what it truly would be within here. Okay, so that kind of sums up our section 8.2, kind of giving you an introduction to hypothesis testing. Once again, writing the statements is the most important part, and the conclusions will come with time.